G'day team, welcome back to another video, and today we're going to be looking at fair games and then also standard deviation and variance later in the video. So in gambling, especially, casinos will rig games so the house will always win. So we're going to say a game is fair if the expected value of x is equal to 0, where x is the expected gain, and we will have to introduce a new variable y to be the expected return. So in a game of chance, a player spins a spinner with 3 outcomes labelled 1, 2, and 3. The money earned is in the table below, so $2, $7, and $6 respectively. So we're going to find the expected return for one spin, the overall expected gain if it costs $3 to spin, and should you play the game. So we're going to let y be the expected return as we said above. So the probability of landing on one section of the spinner is 1/3. So we've got 1/3 times $2 for spin number 1, plus 1/3 times $7, plus 1/3 times $6. Now that will give me my expected return in money value. So I've got 2/3 plus 7/3 is 9/3, plus 6/3 is 15/3, which is $5 expected return. Now, the expected gain, let x be expected gain. Now, that is going to be e of x, which is e of y minus how much it costs to play the game, which is $3. So I've got $5 minus $3, which is $2, positive $2. So that means you're expected to gain $2 every spin you play. So in this case, we would recommend you play the game because you're going to earn money as a gain, okay? So hopefully that helps with the fair games questions. Now let's have a look at variance and standard deviation. Now for a discrete random variable x, we know the expected value or mean is ex, which is mu, which is the sum of the value times the probability. Now the variance of our random variable var of x, or sigma squared, is equal to the sum of the value minus the mean squared times by the probabilities, and the standard deviation is the square root of the variance. Now we do need to know how to use these formulas, but we can do it on the calculator, and I'm going to share the instructions with you now. So this is for a Casio FXCG50 or an earlier model if you have that. So we want to go menu, and then we want to go to statistics, which is number 2. In list 1, we're going to enter our x values. So if I scroll down a little bit, they would be my 1, 2, and 3 here. In list 2, we're going to enter our probability values, and we're going to go calc, which is F2. Now, just double check quickly, go to set and ensure that the 1 var frequency is list 2. You can change that very easily. And if you hit enter and 1 var, okay, you'll find the mean, which is x bar. You'll find sigma, which is the standard deviation, which is sigma x, the median, the mode, and we can find the variance by squaring the standard deviation there. So let's have a look at a question. So I've got a probability density function. We're going to find k such that it's valid, find the mode, find the mean, find the variance and standard deviation, and we can do a quick check on our calculator. So let's find k first. Now we know for a valid probability distribution, probabilities need to add up to 1. So 0.35 plus k plus 0.25 equals 1. Now we know that 0.35 plus 0.25 is 0.6. So k must equal 0.4. So let's put that information into our table. Now the mode is the highest probability, which is in fact 0.4. So that means my mode is 2. Find the mean. So the mean is my expected value, which is the value times by the probability, and we add all of those together. So 2 times 0.4 plus 3 times 0.25. And if I go on my calculator to calculate that, I've got 0.35 plus 2 times 0.4 plus 3 times 0.25, which is equal to 1.9. Now, finding the variance and standard deviation. Now, we do only need to find one, and we can do the square root or the square. So we're going to find the variance to start with. Now, looking at the variance formula, we need to do our value minus the mean squared times by the probability of that value occurring and add them all together. So that first one, I've got the value I have is 1 minus the mean squared times by the probability of it occurring, plus the value of the second one is 2 minus 1.9 squared times the probability, plus the value minus the mean squared times the probability. Now, if I put that into my calculator, 1 minus 1.9 all squared times 0.35 plus 0.1 squared times 0.4 plus 1.1 squared times 0.25, I get 0.59, and that is my variance, so that is sigma squared. Now that means my standard deviation is the square root of 0.59, which is on the calculator, shift answer, 0.768 to 3 significant figures. Now what I want you to do is go into your calculator and check, and you should get those values matching up. So I want you to have a crack at these questions here today. So 7C.3, 1 through 8, 7D, 1 through 9, but not question 7. Thank you for watching, and I will see you in the next video.